So today our topic of discussion is what types of mappings are there in sets. So we now mapping injective, bijective, surjective. So now define of injective. What is injective or injection? A mapping if such that A to B is said to be injective if for each pair of distinct element of A have a image, they are distinct. That's for if image which is also distinct. Now what is surjective? Okay, I will telling you that this is 1 to 1, this is 1 2. What is the definition? If F is a mapping from A to B, then it is said to be surjective if F of A equals to B, and bijective if such that A to B is said to be bijective if F is injective as well as surjective. Let's try an example. Check it. Injective, surjective. Okay, तो एग्जाम्पल क्या है? Let a mapping defined from R to R, so real number to real number, and defined by f of x is equal to 3x plus 1 for all x belongs to real number. Now let's check it. First, for checking injective, we should to do, so let's tell one thing, which if we want to check injective, so if x1 not equals to x2 for all x1 x2 belongs to the domain set capital R, that's from that capital R, then we should to check f of x1 not equals to f x2. If this possible, this done, then we say that f is injective. So now check it out from here to here. Now let x1 x2 belongs to domain set of R. Now f of and x1 not equals to x2, then f of x1 equals to what? So 3x1 plus 1, and f of x2, that's 3x2 plus 1. So now f of x1 minus f of x2 equals to 3 into x1 minus x2 plus 1 minus 1. So 3x1 minus x2. This is not equals to 0. Why? Because x1 x2 are distinct. So x1 minus x2 not equals to 0. If they are equal, then x1 minus x2 equal to 0. But in condition of injective, If x1 not equals to x2, then x1 minus x2 not equals to 0. So they are not equals to 0. For here, so from here f of x1 not equals to f of x2. So f is injective. And now to show, we have to show surjective. Let us take an element y belongs to codomain of R. Then there exists a pre-image x of element y under F. There exists a pre-image x of y under F. Then we have to show f of x equals to y. Therefore, 3x plus 1 equals to y, or x equals to y minus y by 3. Since y belongs to real number, then y minus 1 by 3 belongs to real number. So therefore y has a pre-image. So therefore y has a pre-image y minus 1 by 3 in the domain set R. In the domain set R. Since y is arbitrary, then each element in the codomain set R has a pre-image under F, has a pre-image under F. So therefore F is surjective. So third point is, since F is injective as well as surjective, so F is also bijective. Done.